Hello, how are you? Good morning, good afternoon, good evening. Let's get our cup of coffee and start. Well, we continue with a series of solved integral exercises, but it was essential to pause at this time in order to explain in more detail what we need to be able to integrate. What are these requirements indispensable for us to be able to choose one of the methods or any of the ways to integrate? Until now, we have observed the chain rule and we have observed that we can also use a direct formula. Very well, let's start by analyzing what we need to integrate. We therefore need elements that integrate. Agree. I'm going to put them here as a little box. This little box we have here within this framework is what we are going to integrate inside that little box. We must have a u and we must have a du. Okay, perfect. Where do we get that du? And we are going to get that du by deriving our u. Very well, always on the part of integrating. When we are going to integrate something, that something is composed of several terms. Agree, ADX and something else, you have to choose from these terms. One or which of these terms will be your UIDI, derive it and obtain its du. For example, if you chose as a x, what would be the derivative of x dx would be dx. Okay, this part is x would be your u and this part of the dx would be your du. Agree? Yes. What would happen? For example, if you choose sin of x as your u, the answer would be, what would be your du would be cosine of x by dx. Agree? Yes, very good. Then u of those terms that are going to integrate, it is necessary to take one of these to derive it, and that is going to be their du. Something important before starting to continue with more exercises and with more explanations. This du must be complete. Where complete inside the box, it must be complete. It must not lack any term. Okay, very good. Hey, certain rules that we can take into account here when we evaluate if our du is complete, that we can add numbers, but we cannot add variables. We cannot add another trigonometric function only. We can add numbers, and if it lacks 1, 2, well then we can add u1, 2. Okay, for example, if we took as ux squared, your duty would be 2x dx, yes? And in the given case that you observe that within their integral, they lack this 2 can be added because it is a number. And the rule tells us that if it is a number, we can add it, yes, as long as we comply with a rule. I'm going to put here again the integral symbol for explain that. If you had, I'm going to write here again in this part, the sign of integration. If you had the part of x squared that you took as u, I'm going to put another color here. You took this as a very good. What should you have as du to know that it is complete and be able to proceed with 1.1 method with a formula or with some path to resolve this integral? What they need to have complete this part here on this side 2x dx. Then suppose you had here this x by dx. Very well. And you say, well, I have a dx. Yes, I am missing this. 2 is a number. Yes, I can add it. Also, you can add numbers within an integral. You can add this too. So that now its differential is complete. I'm going to put it on this other side 0, 2 to make it more clearer. In this case, put it with this color. This would be your full differential or your full du. Correct. Note that this du is the same, that what we need is complete. Well, I was incomplete and add it. We complete it with this 2. But as long as we add 1, 2 or a number within an integral, any number, the one that you want, the one you need for your dou, when you place something inside the integral, in this case, numbers have to add on the outside as well. How to, with a contrary position. If you put this 2 in the numerator on the outside, have to put it in the denominator. Okay, that's the rule in this case. We proceed to visualize if it is complete. If not complete, we try to complete it. We can add numbers and nothing more. None another term, no other thing we can add more than numbers. If we add a number within the integral, we have to add on the outside and in the opposite position. If we add 1, 2 on the outside, it is 1/2. If we add a 10 in the part, the external part is 1/10 that will multiply at the end for the solution that remains in our entirety. We are clear, perfect. I will proceed to delete this part that I have just explained to you because another method we have used lately, it is the whole part direct formula. If you remember the direct formula, when will we use it? We will use it only when equal to a formula that has already been established and that we have in the form only at that time. You can see in your form that we have expressed what integral, we have dx, we have an integral of what else for another trigonometric cosine function of x dx. And what other formula you can also see in your form? Integral de aya la xya la x. What else can you observe? All the formulas you can observe on your form, and that are exactly the same in the exercise you are going to perform. You can use it, for example, what do I mean by this X breast? What is that X breast? This X season is our little box. This X season is also the box, is Euler ala X, is the little box. You can ask me good, yes, but why? Then on the form it says, but I observe that it is sine of U by du. That is, why doesn't X minus sine come as you are telling me? You are absolutely right. Note that it is a sine of A multiplied by du. You are absolutely right. And you are also note that it is A to the U for its of U are absolutely right. Why? Because in this case, this U is the variable we are going to use, can be any letter, correct? But in this case, not to put X because it may be X or it may be some other and exemplified or standardized or standardized. This is the correct word, to standardize. Maybe we're 30 times 30, 30, some other variable, some other letter. But that U serves to highlight everything and all that we can use as, in this case, breast contour of this trigonometric part. Okay, very well. And we note that if we have a, we also have U. Okay, if we have Euler ala U, also have this U on this side. Agree then? It makes sense. It would make no sense to use sine of X multiplied by du. And if we know that our U is X good, is also our du, is dx agree? Must match in that part very well. So until now, I want to make it clear. And only what is necessary to integrate, we need to recap a little. We need, now I will use another color, this gray. We need a U and a U. This U, it is extremely important that it is complete. And if it is not complete, we can add what we can add, numbers only, no more numbers. We cannot add nor variables, nor trigonometric functions or anything else. Just, and if we add a number on the inside, we have to add on the outside also in order to be able to balance, but in the opposite position. Okay, perfect. I hope it is clear. Thank you for solving some doubts. And above all, it was important that to watch this part before continuing with more exercises. Yes, we already know what we need to integrate. We already know what that little box is. What does it mean? Our U and our du. Already know that as U, we can take what we want within the terms. We have to integrate after deriving it. We obtain our du, and that du, know that has to be complete. Yes, and we can. In case we do not complete. Okay, perfect. With nothing more to say, we finish the video. If it has any comment, please put it at the bottom. At the bottom, more information is also available from the video on the channel in case that they have any doubts, and no more for the time being. See you in the next episode. Take care of yourselves, drink coffee, rest assured. See you at the next one.